Hello everyone, welcome to Permutations. Today we are going to discuss the topic probability. First I will explain the difference between combinations and permutations and some basic questions and short tricks regarding it. Then at the end of this video we will be discussing some important questions that are asked in competitive examinations. Probability is basically the extent to which something is likely to happen. Same way combination means chances of selection. And permutation means chances of arrangement. That is, first you select, then you arrange it. For example, consider there are three objects, A, B, C. Now, you are choosing two objects out of these three objects. If you are choosing two objects out of these three objects, then combination for this is equal to 3C2. That is, from this 3, you are choosing 2. Then, combination is AB, BC, and CA. That is, here order doesn't matter. In permutation, order matters. In combination, order doesn't matter. That is, AB and BA both are counted as 1. BC and CB both are counted as 1. CA and AC both are counted as 1. So, two objects, if you are choosing two objects from this 3, your combination is equal to 3. Chances of selection is 3 here. But in permutation, if you are choosing two objects from these three objects, your permutation is 3p2. That is, from this 3, you are choosing 2. Then, if you select AB, now order matters in permutation. So, you can arrange this AB as BA as well. That is, when you select AB, you can arrange this AB as BA as well. So, here order matters. A in the first place, in AB, A is in the first place. In BA, A is in the second place. So, order matters. Now, next is BC. You can arrange it as CB as well. Same way, next is AC. You can arrange it as CA as well. So, here permutation is equal to 6. That is, you can choose 3 and arrange it as 6. You are choosing 3. If you are choosing 3 and you can arrange it as 6. So, arrangement is here important. Here selection only, no arrangement in combination. But in permutation, arrangement is the main thing. That is, when you select, you have to arrange it in order. So, order matters. So, this is the difference between permutations and combination. Basic difference. Here, for the same thing, you can see permutation is 6 and combination is 3. That is, permutation is greater than combination when n and r have the same value. That is, for the same value of n and r, permutation is always greater. Now, before starting the questions, we need to remember something. Consider there are 10 objects and you are only selecting 1 out of this 10. Then this can be done in 10 ways. That is, if it is only about one selection, then you can directly write the upper digit. And if you like 9 out of this 10 object, 9 out of this 10 object, then this can be done in 10 ways. Because here, take the difference between 10 and 9, which is 1. So, 10C9 is equal to 10C1. Same way, if 11C2, you can write it as 11 minus 2 is 9. So, 11C2 is equal to 11C9. And 5C3. 5 minus 3 is 2. So, this is equal to 5C2. 4C1. 4C1 is equal to 4 minus 1 is 3. So, 4C3. So, this will go on. Now, if you don't like any of this 10 product, you will have 0 selection. Which means there is a possibility that you don't select any of this object. So, probability of selecting nothing. Probability of selecting 0 object is equal to 1 way. That is, 1 way you can select 0 object. Now, if you like 10 out of this 10 object, this can be done in 1 way. That is, if you like 10 out of this 10 object, this can be done in 1 way. Because probability of lighting all the object is 1. So, here if you take the difference, 10 minus 10 is 0. That is, 10C0 is equal to 10C10. So, this is like, if you are selecting one object out of this n object, this can be done in n ways. And if you are selecting n minus 1 object out of this n object, this can be done in n ways because nc n minus 1 is equal to nc1. if you take difference between n and n minus 1, which is 1. Same way, if you're selecting 0 object out of this n object, which can be done in one way, and if you're selecting n object out of this n object, this can be done in one way because NCM is equal to NC0. Same way, 12C4. Selecting 4 out of this 12. 12 minus 4 is 8 factorial, which is greater than 4 factorial. So cancel 8 factorial in the numerator and in the denominator. After 8, it is 9, 10, 11 up to 12. In denominator, you have 4 factorial. Now 12C4 is same as 12C8. 12 minus 4 is 8. Same way 22C19. Now difference between 22 and 90 is 3 factorial. But 3 factorial is lesser than 19 factorial. So cancel 19 factorial in the numerator and denominator. After 19 it is 20, 21 and up to 22. In the denominator you have 22 minus 19, 3 factorial, which is 1, 2, 3. 1 into 2 into 3. Now this is same as 22C3. 22 minus 19 is 3. And if you look at 25C3, 25 minus 3 is equal to 22. So cancel 22 factorial in the numerator and denominator. After 22, it is 23, 24 up to 25. In the numerator, you have 3 factorial. Now this is same as 25C22. Consider you are purchasing a mobile and there are 11 brands available. Out of this, you only need one mobile. That is, out of this 11, you only need one. If it is only about one selection, you can directly write this upper number. That is 11 ways you can purchase this one mobile. If there are n things available, you only need one thing. If it is only about one selection, then you can directly write this upper number. That is n ways you can purchase this one thing out of this n things. If it is about 5 things, you can purchase one thing out of this 5 in 5 ways. Now, if you like 10 out of this 11 mobiles, that is, if you're selecting 10 mobiles out of this 11 mobiles, you can do it in 11 ways. You can do it in 11 ways. Because here 11 minus 10 is 1. That is, 11C10 is equal to 11C1. 11 minus 10 is 1. 11C1 is equal to 11. That is, if there are n things and you are purchasing n minus 1 things, then your number of selection is n ways. Because n minus 1 is 1. So, NCn minus 1 is equal to NC1. Here difference between n and n minus 1 is 1. NC1 is equal to n. Now, if you don't like any of this 11 mobiles, you are not choosing any of this. That is, probability of 0 selection is 1. There is a probability that you don't choose any of this. That is, probability of selecting 0 is equal to 1. There is a chance that you don't select any of this 11. So, that is 1. Now, if you like 11 out of this 11, if you like all the mobiles, then probability is 1. That is, there is one chance that you like all of this 11. So, probability of selecting all is equal to 1. So, 11C11 is equal to 11C0. 11 minus 11 is 0. That is, here NC0 is 1 and NCn is equal to 1, which is equal to NC0. Now, you can see the difference between combination and permutation questions. Combination is about selection and permutation is about arrangement. Now, in the first question, how many ways 5 students can be chosen from 12 students? So, this is about selection. And in the second case, how many handshakes happen at the party? So, when person A and person B shake hands with each other, you can see both are counted as 1. That is, when person A shakes hands with person B and person B shakes hands with person A, both are counted as 1. So, order doesn't matter here. So, which is equal to combination. And here, permutation question means in how many ways can 7 book be arranged on a shelf. So, this is about arrangement. And here, different arrangement of the letter of the word mathematics. This is also about arrangement. So, let's start our session. In how many ways 5 students can be chosen from 12 students? So here our availability or our resource is 12 and our need is only 5. So from this 12 students, we need 5 students. That is, we have to select this 5 students from this 12 students. Now 12 minus 5 is 7 factorial cancel. Remaining is 8, 9, 10, 11 and 12. And here 5 factorial. 5 goes 2 times in 10. 4 goes 3 times in 12. And 3 and 3 cancel. 2 and 2 cancel. 8 into 9 into 11. 72 into 11 is equal to 2 here. 2 plus 7, 9. And 7 here, 792. Option 4 is your answer. That is, in 792 ways, we can select 5 students out of this 12 students. At the end of a meeting, all the 10 people present shake hands with each other once. The number of handshake altogether is. Here our resource or available people is 10. And to make shake hands with each other, we need 2 people. That is, here our need is handshake. So to make one handshake, we need 2 people. So our need is 2 people. Out of this 10 people, 2 people together make one handshake. So 10 people together mean 10C2 handshakes, which is equal to 10 minus 2, 8 factorial cancel. Remaining is 9 and 10 here and here 2 factorial. So 2 goes 5 times in 10, 9 into 5, 45. Option 2 is your answer. That is, total number of handshake altogether is equal to 45 by this 10 people. In how many ways can 5 members forming a committee out of 10 be selected so that 2 particular members must be included? 2 particular members must not be included. Here available people are 10. That is, our resource is 10. And we need 5 out of 10 means our need is 5. And with these 2 conditions, these 2 datas will change. That is, with the first condition, 2 particular members must be included means out of this 5 positions, 2 seats are already filled. That is, 2 people are selected. 2 seats are reserved. Now we have to select the remaining 3 people out of the remaining people. When 2 people are selected means remaining is 10 minus 2, 8 people available. So out of this 8, we have to select 3 people. So 8C3 is your answer. 8 minus 3 is 5 factorial, cancel. Remaining is 6, 7, 8 and denominator 3 factorial. 2 into 3, 6 cancel. 7 into 8, 56. Now second is 2 particular members must not be included. That is, 2 people are rejected means out of this 10, remaining people are 8. That is, 2 people must not be included means out of this 10, we have to reject 2 people. So remaining people are 8. So out of this 8, we have to select 5 members. Out of this 8, we have to select 5 members. So 8C5 is your answer. Now 8C5 is equal to 8C3. 8 minus 5 is 3. 8C3, which is also 56. So option 2 is your answer. A team of 4 has to be selected from 6 boys and 4 girls. How many different ways a team can be selected if at least 1 boy must be there in the team? At least 1 boy means it can be 1 boy or 2 boy or 3 boy or up to maximum 4 boys, because this team of 4 include only 4 people. Instead of calculating the possible selection of these 4, just calculate the possible selection of 0 boys included in this team of 4, because this at least 1 doesn't include 0. So if you take the possible selection of 0 boys included in this team of 4 and then subtract that possible selection from total selections, then you will get your answer. That is, subtract the possible selection of 0 boys from the total selection. That is your answer. Here total availability is equal to 6 plus 4, 10. So our resource is 10. Our available people are 10. But our need is only 4. So we have to select 4 people from this 10 people. So 10C4 is our total selection. From this, calculate the possible selection of 0 boys included in this team of 4. That is, from the 6 boys, we are selecting 0 boys. That is, no boy included. Now, remaining members should be 4. So that 4 members should be selected from this 4 girls. So from this 4 girls, we are selecting all the 4 girls. Now team of 4 is formed with 0 boys. 0 plus 4 is 4 member team. Now subtract these possibilities. That is 10C4 means 6 factorial cancel, remaining 7 into 8 into 9 into 10 divided by 4 factorial. Minus 6C0 is equal to 1, 4C4 is equal to 1. Now this is equal to 4 into 2 is 8 cancel. Now 3 goes 3 times in 9. 7 into 3, 21. So 210 minus 1 is equal to 209. Option 4 is your answer. A committee of 5 persons have to be formed out of 3 women and 6 men such that there can be at most 3 women. How many ways can such a committee be formed? Here, our total availability of persons is 6 plus 3, 9. Our resource is 9 and we only need 5 out of it. So our need is 5. Now, out of this 9 people, we can select 5 people in 9C5 ways. Out of this 9, we can choose 5 people in 9C5 ways. Now this is the total possibility of selection. And here there is a condition, that is at most 3 women. At most 3 women means it can be 0 woman, it can be 1, it can be 2 or up to maximum 3 women. That is, we can choose any of these 3 women. Here maximum woman is 3. Here availability is only 3 women. And we can choose any of these 3 women means we can choose any of these 9 people. So there is no restriction with this condition. By this condition there is no restriction. Because we can choose any of these 3 women. So if we can choose any of these 3 women, which means we can choose any of these 9 people. There is no restriction. So here 9 is not changing and this 5 is not changing. So 9C5 is our answer. That is 9C5 means 9 minus 5 is 4 factorial. In the denominator, here 5 factorial cancel each other. Now remaining is equal to 6, 7, 8 and 9 in numerator. Now 2 into 4, 8 cancel, 3 goes 3 times in 9. 6 into 7, 42, 42 into 3. 42 into 3 is equal to 40 into 3, 120, 3 into 2, 6. So 126, option A is your answer. Now if you don't understand this, there are 3 women available and out of this at most 3 women means it can be 0 woman, it can be 1 woman, it can be 2 women or it can be 3 women, maximum of 3 women. Now if 0 woman means other members, all the members should be men. That is, there are 6 men available. Out of this 5 should be men. And 1 woman included means 4 men is remaining teammates. 2 women included means 3 men is remaining team. 3 women included means 2 men is remaining teammates. Now if you calculate this all is equal to 9C5. If you add these together. Now if it is at most 2 women, consider this as at most 2 women. Then what will be your answer? At most 2 means it can be 0, it can be 1, it can be 2. Maximum of 2. But here we have 3 women available. So we have to subtract that possibility of including 3 women in the committee. That is, possibility of including 3 women in the committee is equal to, we have to choose 3 out of this 3 women. Then if 3 people are women, then the remaining 2 people should be men. That is 6C2. That is, we have to subtract 3Z3 into 6C2 from this 9C5. If it is about 2 women. If it is about 2 women. At most 2 women. This is at most, okay? At most. So, it can be 0 woman, it can be 1 woman, it can be 2 women in the committee. But no 3 women. So, if 3 women included, from this total possibilities, we have to subtract this 3 women possibilities from this total possibilities. But here we have at most 3 women, which means you don't have to subtract anything because you can choose any of these 3 women. That is, you can choose any of this 9 people. So 9C5 is equal to 126. A committee of 5 is to be formed from a group of 12 students consisting of 8 boys and 4 girls. In how many ways can the committee be formed? It contains at least 3 girls. There are 4 girls available. So at least 3 girls should be included, means it can be up to minimum of 3 girls or maximum of 4 girls. Now if you are choosing 3 girls for your committee, then these 3 girls are selected from this available 4 girls. 4C3 is a selection of 3 girls. And 3 girls included means remaining 2 should be boys. So these 2 boys are selected from this available 8 boys. So 8C2 is the selection of 2 boys. Or you can have 4 girls in your committee. So this is 3 girls selection of the committee. Now if you are including 4 girls in your committee, selection is different. That is, if you are choosing 4 girls, these 4 girls are choosing from this available 4 girls. And remaining should be 1 boy. This 1 boy is selected from this 8 boys. So this is equal to 4C3 is 4 and 8C2 means 6 factorial cancel, remaining is 7 into 8. Here you have 2 factorial. Plus 4C4 means 1, 8C1 means 8. Now 2 goes 2 times in 4. 7 into 8, 56 into 2 is 112. And here you have 8 which is equal to 120. So option A is your answer. That is, if the committee include 3 girls, so this committee can be selected from 12 students in 112 ways. That is, if your committee include 3 girls, this committee can be selected in 112 ways. But if your committee include 4 girls, that committee can be selected from this 12 student in 8 ways. So total possible ways is equal to 120 ways, including 3 girls or 4 girls. Total 120 ways. Always remember here into means and. 3 girls and 2 boys. Or means plus. 4 girls and 1 boy. So this way you have to remember it. If it is 3 or 4, means consider the possible selection of 3 girls. Then add possible selection of 4 girls. A committee consists of 4 men and 3 women selected from 7 men and 6 women. One of the selected women is chosen as chairman. Find the number of ways of selecting the chairman. Here this 4 men is selected from the 7 men in 7C4 ways. 4 men from 7 men. Now this 3 women is selected from this 6 women in 6C3 ways. Now 7C4 into 6C3 is the possible selection of committee. Now one of the selected women is chosen as chairman means here selected women are 3. So from this selected woman we will select a chairman. So this selection of chairman is done from this selected 3 women. So multiply the possibilities of chances of selecting chairman. Here from this 3 women we will choose any of this 3 as chairman in 3C1 ways. So multiply it because here we already selected 3 women. Now this 3 form this 3C1. So multiply it. Now this is the possible selection of chairman. 3C1 is equal to 3. So option 2 is your answer. From 6 boys and 4 girls, 5 students are to be selected for admission to a course. In how many ways can this be done if there must be exactly 2 girls? Exactly 2 girls means only 2 girls can take admission to this course. There are 5 students are selected for this course. So out of this, 2 are girls. So these 2 girls are selected from this available 4 girls in 4C2 ways. So remaining 3 should be boys which are selected from 6 boys. So this 3 boys selected from available 6 boys. So 4C2 into 6C3 is the selection. Now 4C2 means 2 factorial cancel, remaining is 3 into 4 divided by 1 into 2 into 3 factorial cancel, remaining is 4 into 5 into 6. In denominator you have 3 factorial. Now 6 cancel. Here 2 goes 2 times in 4. Now 6 into 20, 120. Option 4 is your answer, none of the above. It is compulsory to answer 10 questions in an examination, choosing at least 4 questions from each part A and B. If there are 6 questions in part A and 7 questions in part B, in how many ways can 10 questions be attempted? Here, choosing 10 questions is compulsory. And you can choose this 10 questions from part A or part B. Part A contains 6 questions and part B contains 7 questions. Here, at least 4 is a condition. So, at least 4 is mandatory means you can choose minimum of 4. You should choose minimum of 4. Or you can choose 5 or maximum of 6 questions. 7 is not possible here because if you choose 7 from part B, here you should choose 4 from part A because choosing at least 4 is mandatory. So 7 plus 4 is 11, which is not necessary. We only have to attend 10 questions. So if you are choosing 4 questions from part A, this can be done in 64 ways. Part A contains 6 questions. Now 4 questions completed. Remaining 6 questions you should attend from part B in 76 ways. Or you can choose 5 questions from part A. 5 questions from part A means 65 ways. If you attend 5 questions, remaining 5 from part B in 75 ways. Or you can choose 6 questions from part A. That is in 66 ways. So 6 questions attended, remaining 4 questions from part B in 74 ways. Now this is your answer. 64 means 4 factorial cancel, remaining is equal to 5 into 6. Here you have 2 factorial. 76 is equal to 7 plus 65 is equal to 6. 75 is equal to 5 factorial cancel, remaining is equal to 6 into 7 numerator, and you have 2 factorial in the denominator, plus 66 is 1, 74 means 4 factorial cancel, remaining 5, 6, 7 in numerator, and you have 3 factorial in the denominator. Now this is equal to 2 goes 3 times in 6, 2 goes 3 times in 6, and here 2 into 3, 6 cancel. Now 7 into 3, 21, 21 into 5 is equal to 105 plus, and 21 into 6 is equal to 126, and here 7 into 5, 35, which is equal to 26 plus 5, 31, 31 plus 35 is equal to 66. So 266 ways. Option C is your answer. That is, if you are choosing 4 questions from part A, then you can attend 10 questions in 105 ways. If you are choosing 5 questions from part A, then you can attend 10 questions in 126 ways. If you are choosing 6 questions from part A, you can attend 10 questions in 35 ways. And total, you can attend 266 ways with this at least 4 condition. How many triangles can be formed using 10 points in a plane, out of which 4 are collinear? Here, our availability or our resource is 10 points. And we need to form triangles. So, our need is 3. Because to form a triangle, we need 3 points. Now, total possibility of forming triangles from this 10 point is 10C3. Because from this 10 point, we need 3 points to make a triangle. So 10C3 ways we can make triangles from this 10 points. But here we have a condition. That is, we have 4 points which are collinear. So 4 points are collinear means these 4 are on a same straight line. Now the remaining 6 are here and there. We don't know where it is. With this we can form triangle, but with this 4 we cannot form triangle, because if you take 3 straight line points, you cannot make a triangle. You can make a straight line. So, subtract possibility of forming triangles from this 4 points. From 4 points, we can form 4C3 triangles. So, subtract the possibility of forming triangles from this 4 points, from this total possibility. So, here 10C3 means 10 minus 3, 7 factorial cancel in numerator and denominator. Remaining is equal to 8 into 9 into 10 divided by 3 factorial. Now you have 4C3, which is equal to 4. Now 2 goes 4 times in 8, 3 goes 3 times in 9. 120 minus 4 is equal to 116. Option B is your answer. How many diagonals are there for a 12-sided polygon? For a 12-sided polygon, there are 12 vertices. Now, to form a diagonal, you need 2 vertices. Okay, consider this as 12-sided polygon. Now, when you take 2 adjacent vertex, these 2 vertex together form a side. But we need diagonal. So, if you take this vertex, these 2 can form a diagonal. Same way, if you take these 2 vertex, these 2 can form a diagonal. And these 2 also can form a diagonal. And if you take this vertex, these 2 vertex together form a side. But if you take this one, this will form a diagonal. This will also form a diagonal. So this will continue. Which means from this 12 vertex, you need 2 vertex together to form a diagonal. But these 2 vertex together also form sides. So for 12-sided polygon, there are 12 sides are there. So these 2 adjacent vertex together form 12 sides. So subtract this 12 side from this 12C2. Then you will get number of diagonals. So 12C2 means 12 minus 2 is 10 factorial cancel. Remaining is 11 and 12. Here you have 2 factorial minus 12. Which is equal to 2 goes 6 times in 11. 66 minus 12. Which is 54. So option D is your answer. The number of all possible selection which a student can make for answering one or more question out of 8 given question in a paper when each question has an alternative is. Here there are 8 questions. Now each of this 8 question has an alternative. That is, first question has 2 alternatives. Either you can answer A or you can answer B. Now all these 8 questions has 2 alternatives. And this first question you can answer in 3 ways. That is, either you can answer A or you can answer B, or you can choose not to answer the first question. There is no answer for the first question. You are not answering A and B. That is, this can be done in 3 ways. So, the second question also you can done in 3 ways. Third also in 3 ways. So, each of these 8 questions you can answer in 3 ways. Now, this 3 repeated for 8 times. So, all the possible selection to answer 8 questions is equal to 3 raised to 8. All the possible selection to answer 8 questions is 3 raised to 8. Total possibility is 3 raised to 8. But here we have to subtract something. Because there is a condition, that is, one candidate must answer one or more question. So, at least one is a condition. That is, candidate cannot give blank sheet. Here, in this 3 ways, not answering a question is included. So, this 3 raised to 8 include not answering this 8 question. That is, not answering the first question, not answering second question. So, not answering up to 8 question. That is, this 3 raised to 8 include possibility of blank sheet. So, we have to subtract that blank sheet possibility from this 3 raised to 8. That is your answer. So, 3 raised to 8 can be written as 3 raised to 4 into 2. That is 3 square raised to 4. 9 raised to 4 minus 1. Now, 9 raised to 4 is equal to 9 raised to 2 into 2. 9 square is equal to 81. So, 81 square minus 1. 1 square is 1. 8 into 1 into 2 is 16. 8 square 64 plus 1 65. So, 6561 minus 1 is equal to 6560. So, option B is your answer. There are 4 balls of color red, green, yellow and blue. In how many ways 2 balls can be selected such that one of them is red or blue? Here there are total 4 balls and out of this we need 2 balls. So this can be done in 4C2 ways. But we have to subtract something because we have a condition. Out of the selected 2 balls, one of them must be red or blue. So subtract the chances of getting no red and no blue. No red and no blue means red cancel, blue cancel. Remaining is 2 balls. So out of these 2 balls, if you select 2 balls, this can be done in 2C2 ways. So subtract 2C2 from 4C2, then you will get your answer. 4C2 is 6 and 2C2 is 1. So 6 minus 1, 5 ways. Option D is your answer. Actually, this 1 means chances of getting green and yellow. So when you get green and yellow, this doesn't include red or blue. So this is the one case which is 2C2. Now before solving the next question, just remember certain things. Here for n identical things, total possible selection for n identical things can be done in n plus 1 ways. Total possible selection means all the possible selection, which includes 0 selection as well. Then at least 1 out of n identical things can be done in n ways. That is, this at least 1 selection means this doesn't include 0 selection. So subtract 0 selection from this n plus 1. So n plus 1 minus 1 is equal to n ways. And for n different things or n distinct things, total possible selection for n different things can be done in 2 raised to n ways. So this includes 0 selection. Then at least 1 selection out of n different things can be done in 2 raised to n minus 1 ways, because this doesn't include 0 selection. So subtract 0 selection, that is 1 from 2 raised to n. That is, just remember n plus 1 for n identical things and 2 raised to n for n different things. Then if you subtract 1 from these two, you will get n ways and 2 raised to n minus 1 for at least 1. The number of ways in which 1 or more balls can be selected out of 10 white, 9 green and 7 black balls is. Here, probability of selecting 1 or more balls is equal to this 10 white balls you can select in 11 ways. That is, you can choose not to have a white ball. That is, you can decide to select 0 white ball, or you can select 1 white ball or 2 white ball or up to 10 white ball. So this can be done in 10 plus 1, 11 ways. Same way, 9 green balls you can select in 10 ways and 7 black ball you can select in 8 ways. But you have to subtract something because we have a condition. You should select 1 or more balls. That is, at least 1 ball is mandatory. You should select at least 1 ball. But here this total possibility 11 into 10 into 8 include selecting none of this ball. That is, here if you are selecting 0 white ball, 0 green ball and 0 black ball, this selection is included in this total possibility. So subtract one such case. That is, if you are not selecting any of this ball, subtract one such case. So total possibilities is equal to 880 minus 1, 879. Option D is your answer. Given 5 different yellow balls, 4 different black balls and 3 different white balls, then the number of combinations of balls that can be chosen taking at least 1 yellow and at least 1 black balls are. Here this is about n different things. That is, here all the yellow balls are different, all the black balls are different, all the white balls are different, all the given balls are different. So this is about total possible selection of n different things. Here all these 5 yellow balls are different. So total possible selection of all these 5 yellow balls is equal to 2 raised to n. Here n is equal to 5, that is 2 raised to 5. That is, here if you are choosing none of this ball, that is, if you are selecting 0 of this ball, then this can be done in 5C0 ways. If you are selecting any one of the ball, this can be done in 5C1 ways. If you are choosing 2 balls, selection is 5C2. If you are choosing 3 balls, selection is 5C3. If you are selecting 4 balls, selection is 5C4. And if you are choosing all the balls, then selection is 5C5. So this is equal to 1 plus 5 plus 10 plus 10 plus 5 plus 1, total 32 ways. So here all the possible selection is 32 ways, means here 2 raised to 5 is also 32. Now that is why all the possible selection of n different things is equal to 2 raised to n. But here in question it says that we need at least 1 yellow. Question is about at least 1. So at least 1 selection can be done in 2 raised to n minus 1 ways. Because here this 2 raised to n, total possible selection includes 0 selection as well. So we have to subtract this 0 selection from this total possible selection. So 0 selection is 1. So subtract 1 from. That is not choosing any of the ball from total possible selection. So that is at least one selection. Now you know the concept. Here 2 raised to n means nc0 plus nc1 plus nc2 plus etc. up to ncn is equal to 2 raised to n. Here we have 5 different yellow balls, 4 different black balls and 3 different white balls. 5 yellow, 4 black and 3 white balls. And we need at least one yellow. At least one yellow selection can be done in 2 raised to 5 minus 1 ways. And at least one black ball selection can be done in 2 raised to 4 minus 1 ways. And here this is and. So you have to multiply together. And here we need total number of combination of balls. So we have 3 white ball as well. So here nothing is given about white ball choice. So you can have white ball or you cannot have white ball. So this can be done in 2 raised to 3 ways, 2 cube ways. Because total possible selection of 3 white ball is equal to 2 cube ways. These 3 white balls are different. So as per the condition, our answer is equal to 2 raised to 5 minus 1 into 2 raised to 4 minus 1 into 2 cube, which is equal to 2 raised to 5 is equal to 32. 32 minus 1 is 31. 2 raised to 4 is equal to 16. 16 minus 1 is 15. So 2 cube is 8. Now 15 into 8 is 120. 120 into 31, which is equal to 3600. 120 into 30 is 3600 plus 120, which is 3720. Option 3 is your answer. A bag contains only red, green and white balls. The probability of selecting a red ball from the bag at random is 1 by 3 and that of selecting a white ball at random is 1 by 2. If the bag contains 9 green balls, the total number of balls in the bag is, we have red balls, green balls and white balls. Now probability of selecting red balls is equal to 1 by 3, selecting white ball is 1 by 2 and you have total 9 green balls. Now you already know probability of total event is 1. That is probability of selecting red plus probability of selecting green plus probability of selecting white is 1. Then probability of selecting green is equal to 1 minus 1 by 3 plus 1 by 2. Sum of these two, which is equal to 1 minus 5 by 6, which is 1 by 6. So probability of getting or selecting a green ball as 1 by 6 means here this 1 by 6 denote probability of getting a green ball out of the total number of ball. Here you are only selecting one ball and there is no other conditions. So simply probability of getting a green ball is 1 by 6 means green balls are 1 by 6th of the total number of ball, which means here one part is equal to 9. There are total 9 balls. Then total number of balls are 6 part. So 6 part is equal to 6 into 9, 54. So there are total 54 balls. Option 4 is your answer. A bag contains 2 red, 3 green and 2 blue balls. 2 balls are drawn at random. What is the probability that none of the ball drawn is blue? Here this is like probability of event, that is probability of favorable outcome by probability of total outcome. Now this is equal to, there are total 2 plus 3 plus 2, 7 balls available and out of this we need 2 balls. So 7C2 is the total selection. So out of 7 we need 2 balls and our outcome, favorable outcome is none of the ball drawn is blue. So when you draw this 2 balls, none of them should be blue. So we can ignore this 2 blue balls. Remaining is 2 plus 3, 5 balls. So out of this 5, we should draw 2 balls. So 5C2 is the favorable outcome, which is equal to 5 minus 2, 3 factorial cancel. Remaining is 4 into 5 divided by 2 factorial. Here 5 cancel, remaining 6 into 7 divided by 2 factorial. 2 factorial cancel. And here 20 by 42, which is equal to 10 by 21. Option 3 is your answer. A bag contains 4 red and 3 blue balls. If 2 balls are drawn from this bag at random, what is the probability that they are of different color? Here, probability of total outcome. There are 4 plus 3, 7 balls available. Out of this, we need 2 balls. So 7C2 is the total selection. From the 7, we should select 2 balls. And our favorable outcome is they are of different color. The selected 2 balls should be of different color. That is, one should be red and other should be blue. When you select 2 balls, one should be red and other should be blue. So this favorable outcome is equal to, from this 4 red, we should select 1 red. And from this 3 blue, we should select 1 blue. So 4C1 into 3C1 is the probability of favorable outcome. That is, these 2 balls should be of different color. This one is red and other one is blue. So 4C1 into 3C1 means 4 into 3, 12. Divided by 7C2 means 5 factorial cancel, remaining is 6 into 7 divided by 2 factorial. Now 2 goes 3 times in 6, 3 goes 4 times in 12. So 4 by 7. Option 1 is your answer. A bag contains 5 blacks and 6 white balls. 2 balls are drawn at random. What is the probability that the balls drawn are white? Here, total probability, total selection is, total balls are 5 plus 6, 11. So availability of balls is 11 and we need to select 2 balls. So our need is 2. So total selection is 11C2. Now favorable outcome, which is balls drawn should be white. So this selected 2 balls should be white means these 2 balls should be selected from the 6 balls. Then our favorable outcome is 6C2. If you select these 2 balls from the 6 white ball, you will get 2 balls as your outcome. Now 6C2 is equal to 4 factorial cancel, remaining 5 into 6 divided by 2 factorial. Here 9 cancel, 10 into 11 divided by 2 factorial. 2 factorial cancel and 5 goes 2 times in 10, 2 goes 3 times in 11. So 3 by 11. Option 4 is your answer. A box contains 6 red balls and 4 green balls. 4 balls are selected random from the box. What is the probability that 2 of the selected balls will be red and 2 will be green? Here, if you look at the options are fractional values. So this is probability of even. Either you can understand from the question, or if you look at the option, this is in fractional form. So this is probability of even means probability of event is equal to probability of favorable outcome divided by probability of total outcome. So here we have 6 red balls and 4 green balls, and we have to select 4 balls from it. So our total resource, total availability is 6 plus 4, 10. Out of this we have to select 4 balls. So our need is 4. Now 10C4 is the total selection. And we need favorable outcome. That is, our output is, you should get 2 red and 2 green. 2 red and 2 green. And means into. That is 2 red and 2 green. So this 2 red should be selected from this available 6 red. So 6C2 is the selection of your 2 red. And 2 green means this 2 green should be selected from this available 4 greens. So 4C2 is the selection of this 2 green. Now 6C2 into 4C2 is the favorable outcome. 6C2 means 4 factorial cancel, remaining 5 and 6 here and 1 and 2 denominator. 4C2 means 6 ways. 10C4 means 6 factorial cancel, remaining 7, 8, 9, 10 in numerator and remaining 4 factorial in the denominator. Now 4 into 2 is 8. 3 goes 3 times in 9. Now 5 goes 2 times in 10. 3 into 2, 6 cancel. 2 into 3, 6 cancel. So 3 by 7 is the total outcome. Option 4 is your answer. A bag contains 7 white, 6 red and 9 black balls. 2 balls are drawn at random. The probability that the ball will be black is, here, this is probability of favorable outcome by total outcome. Total available balls are 7 plus 6 plus 9, 22 balls. And we need to select 2 balls out of this 22. So total outcome is 22C2, 2 from 22. Now, favorable outcome is the ball should be black. when you draw 2 bolts, these 2 bolts should be black. So to make it black, we should draw it from 9 black. So favorable outcome is equal to, out of this 9 black bolt, we should get 2 black bolts. So 9C2 is the favorable outcome. Now this is equal to 7 factorial cancel, 8 into 9 by 2 factorial divided by 20 cancel, 21 into 22 divided by 2 factorial. 2 factorial cancel, and here 3 goes 3 times in 9, 3 goes 7 times in 21. 2 goes 11 times in 22, 2 goes 4 times in 8. So this is 12 by 77. Option 2 is your answer. An urn contains 10 black and 5 white bolts. 2 bolts are drawn from the urn one after the other without replacement. What is the probability that both drawn bolts are black? Here you can do this in 2 methods. I will explain both the methods. Here this is one after the other event. There are 2 events, that is drawing first ball is first event and drawing second ball is second event. Now to get the probability of total event, you should multiply these 2 events together. Here total number of balls are 10 plus 5, 15. Out of this 15, you should select 1 ball. So 15 is your total selection. 15 C1 is your total selection, because you are selecting 1 ball out of this 15. Then you can directly write 15 here. Then probability of favorable outcome means when you select 1 ball, it should be black. It should be black means you should select that 1 ball from this 10 ball. So your favorable outcome is 10C1. 10C1 means 10 itself. Now second event is, you already chose 1 black ball. Remaining is equal to 10 minus 1, 9 black ball. So total number of balls are 9 plus 5, 14. So total outcome for the second event is equal to 14. Now when you select 1 ball from this 14, it should be black again. That is your favorable outcome. So to get a black ball from this 14 ball, you should select it from this 9 black ball. So 9C1 is the favorable outcome for the second event. 9C1 means 9 again. Now both the balls selected are black. So you don't have to worry about the arrangement of this event. If this is a different color, if you have to select a different color in the second event, then you should arrange it. That is, here there are 2 events happen. So arrangement can be done in 2 factorial ways. But here both the balls selected are black. So you should divide it with 2 factorial. 2 factorial by 2 factorial is equal to 1 itself. So here both the balls are black. So you don't have to worry about the arrangement. Otherwise you have to arrange it as well. Now this is equal to 5 goes 3 times in 50, 5 goes 2 times in 10, 3 goes 3 times in 9, 2 goes 7 times in 40, 3 by 7. Option D is your answer. Here in the second method, here probability of total outcome means you should select 2 balls from this total 15 balls. So 15C2 is your total outcome. Now you are selecting 2 black balls. So this 2 black ball, to get a 2 black ball, you should select it from 10 black balls. So 10C2 is your favorable outcome. Now if you solve this, you will get 3 by 7. A basket contains 6 blue, 2 red, 4 green and 3 yellow balls. If 3 balls are picked up at random, what is the probability that none is yellow? Here this is probability of favorable outcome by total outcome. Total balls are 6 plus 2 plus 4 plus 3, which is 15. So from this 15 ball, we have to pick up 3 balls. We have to select 3 balls. Our need is 3 and our resource is 15. So 15C3 is the total outcome. Now, our favorable outcome is none should be yellow. Here, none of the balls should be yellow, which means you have to ignore this 3 balls. Remaining, we have 6 plus 2 plus 4. That is, you should pick this 3 balls from this total 12 balls. That is, just ignore this 3 balls because our outcome should not be yellow. So 12C3 is your favorable outcome. Now this is equal to 9 cancel, remaining 10 into 11 into 12 divided by 3 factorial. Here 12 cancel, remaining 13 into 14 into 15 divided by 3 factorial. 3 factorial cancel, and here 3 goes 4 times in 12, 3 goes 5 times in 15, 5 goes 2 times in 10 and 2 goes 7 times in 14. So this is equal to 44 divided by 13 into 7 is 91. Option D is your answer. A basket contains 3 blue, 2 green and 5 red balls. If 3 balls are picked up at random, what is the probability that at least one is red? Here this is also like probability of favorable outcome by total outcome. But here we need at least one red as our favorable outcome. At least one red means there are total 5 red. So it can be 1 red, 2 red, 3 red, 4 red or 5 red. So instead of calculating probability for all these 5 outcomes, just calculate the probability for no red. That is probability of getting 0 red. And subtract it from the total outcome. Probability of total event is 1. Now subtract probability of getting no red. That is 1 minus probability of getting no red is your answer. That is probability of getting at least 1 red means 1 minus probability of getting no red. Now this is equal to 1 minus, here total outcome is equal to total balls are 3 plus 2 plus 5, 10 balls. Out of this 10 ball, you are choosing 3 balls. So 10C3 is the total outcome. Now here our favorable outcome is no red. We are taking 1 minus no red, which is our at least 1 red category. So no red means you should not consider this 5 red balls. So you have to pick this 3 balls from this 3 plus 2, 5 balls. So 5C3 is the favorable outcome, that is no red. Now 1 minus no red is equal to at least 1 red. Now this is equal to 1 minus 5C3 is equal to 3 cancel, remaining 4 into 5 divided by 2 factorial divided by 10C3 is 7 cancel, 8, 9, 10 divided by 1, 2 and 3. Now 2 goes 2 times in 4, 5 into 2 is 10 cancel, 3 goes 3 times in 9 and 2 goes 4 times in 12. Now this is equal to 1 minus 1 by 12. 1 minus 1 by 12 means 11 by 12. Option C is your answer. A basket contains 6 blue, 2 red, 4 greens and 3 yellow balls. If 5 balls are picked up at random, what is the probability that at least one is blue? Here instead of calculating the probability of getting one blue, just calculate the probability of getting no blues. Then subtract it from this total probability. That is 1 minus no blue is at least getting 1 blue. So 1 minus, find the probability of getting no blues. Here total number of balls are 6 plus 2 plus 4 plus 3, total 15 balls. Out of this 15 balls, we should select 5 balls. So 15C5 is the total outcome. Now favorable outcome is getting no blue. That is, here when you select 5 balls, you should not get blue balls. So ignore the 6 blue balls. Remaining balls are 9 balls. So out of this 9 balls, you should select 5 balls. Then you will not get blue balls. Here 1 minus 9C5 means 5 factorial cancel, remaining is equal to 6, 7, 8, 9 divided by 4 factorial. Divided by 15C5 means 10 cancel, 11, 12, 13, 14, 15 divided by 5 factorial. Now 3 into 4, 12 cancel, 2 goes 7 times in 15, 5 goes 3 times in 15. 7 and 7 cancel, 2 into 3, 6 cancel, 4 goes 2 times in 8 and here 3 goes 3 times in 9. So 6 divided by 1 minus 6 divided by 11 into 13 is 143. So option A is your answer. This is equal to 137 divided by 143. A basket contains 6 blue, 2 red, 4 green and 3 yellow balls. If 4 balls are picked up at random, what is the probability that 2 are red and 2 are green? So here our favorable outcome is 2 red and 2 green. Here and means multiplication. So here total outcome means total number of balls are 6 plus 2 plus 4 plus 3, which is equal to 15. So out of this 15 we should select 4 balls. So 15, so C4 is the total outcome. Now favorable outcome means 2 red and 2 green. So ignore blue balls and yellow balls. Now we have 2 red and 4 greens. So out of this 2 red, we should draw 2 red. So 2C2 is the selection. And out of this 4 green, we should select 2 green. So 4C2 is the selection. Here, this is 2 red and 2 green. Favorable outcome. So multiply. Now 15C4 means 11 cancel, remaining is 12 into 13 into 14 into 15 divided by 4 factorial. And here 2C2 means 1, 4C2 is equal to 6. And here 4 into 3, 12 cancel, 2 goes 7 times in 14 and 3 goes 2 times in 6 and 3 goes 5 times in 15. So 2 divided by 7 into 5, 35. 35 into 13. 35 into 13 is larger number. So option D is your answer. That is 2 by 445. A bag contains 7 white and 9 black balls. 2 balls are drawn in succession at random. What is the probability that one of them is white and the unseen other is black? Here, succession at random means you're picking balls one after the other. One after the other. Now, when you pick 2 balls, your result is 1 black and 1 white. So, we don't know which one you picked first. Either it can be white or it can be black. So, arrangement of these 2 balls can be done in 2 factorial ways. Here, no color is repeating. So, this arrangement is done in 2 factorial ways. And here, first selection is either white or black. Consider it as white. Now, total number of balls are 7 plus 9, 16. So, out of the 16 balls, you are picking 1 ball. So, total selection is 16. Now, when you pick the 1 ball, it must be white. So, to get a white ball, you should select it from the 7 white balls. So, 7C1 means 7 is the favorable outcome. Now, the second event is getting a black ball. Now, after you pick the white, remaining whites are 7 minus 1, 6 white. So, total number of balls available are 6 plus 9, 15. So, for the second event to happen, total outcome is 15. That is, total number of balls are 15. You are selecting one from this 15. And that should be black. That second ball should be black. So, to get a black ball from this 15 ball, you should select that ball from this 9 black ball. So, 9C1 means 9 is the favorable outcome in the second event. Now, we don't know which event happened first. Either you picked white or you picked black first. So, arrangement of these 2 balls can be done in 2 factorial ways. Now, 2 goes 8 times in 16 and 3 goes 5 times in 15, 3 goes 3 times in 9. Now, this is 21 divided by 40. So, option B is your answer. Or you can directly do this question in, you are picking 2 balls. 2 balls from this total 16 balls. So, 16C2 is your total outcome. Now, your favorable outcome is getting white ball and black ball. That is, these 2 balls should be white and black. So, this white ball can be selected from the 7 balls in 7C1 ways. And 1 black ball can be selected from this 9 black ball in 9C1 ways. So, 7C1 into 9C1 is the favorable outcome. Getting 2 balls, that is white and black. And total outcome is 16C2. Now, this is also equal to 21 by 40. A box contains 4 red, 5 green and 6 white ball. A ball is drawn at random from the box. What is the probability that the ball drawn is either red or green? Here, this is OR. So, you should add plus between the events. And this is about single selection. So, you can directly write the numbers. So, probability of favorable outcome divided by total outcome. Total number of balls are 15. So, you are drawing one single ball out of this 15 ball. This can be done in 15C1 ways. That is 15 ways. Now, your favorable outcome is when you draw one ball out of this 15, you may get 1 red or 1 green. So, you can ignore this 6 white balls. So, to get 1 red out of this 15, you should select that 1 ball from this 4 red. So, this can be done in 4C1 ways. That is 4 ways. And or if you are getting green ball, when you select 1 ball out of this 15, If you are getting green ball, then you should select that ball from this 5 green balls. So this can be done in 5C1 ways. That is 5 ways. Total number of favorable outcome is equal to 9 divided by total outcome 15. 3 goes 3 times in 9, 5 times in 15. So 3 by 5, option B is your answer. Here, this is OR. If it is red and green, you can multiply it. A basket contains 2 blue, 4 red, 3 green and 5 black balls. If 4 balls are picked at random, what is the probability that either 2 are blue and 2 are red, or 2 are green and 2 are black? Here we have OR. So add plus between the events. Now probability of total outcome. Total outcome means total number of balls are 2 plus 4, 6, 6 plus 3, 9, 9 plus 5, 14. So there are 14 balls. Out of this, we should select 4 balls. So 14C4 is the total outcome. Now favorable outcome means when you select 4 balls out of this 14, it should be 2 blue and 2 red. It can be 2 blue and means multiply. 2 red. Or means plus. Or it can be 2 green and 2 black. So this 2 blue and 2 red, we can select it from this blue and red. 2 blue can be selected from 2 blue in 2C2 ways, and 2 red can be selected from this 4 red in 4C2 ways. Or means plus. And we need 2 green and 2 blue as well. So this can be selected from green and black. 2 green can be selected from this 3 green in 3C2 ways, and 2 black can be selected from this 5 black in 5C2 ways. Now this is equal to 14C4 means 10 cancel, remaining 11, 12, 13 and 14 divided by 4 factorial. Now here 2C2 is 1, 4C2 is 6, plus 3C2 is 3 and 5C2 means 3 cancel, remaining 4 into 5 divided by 2 factorial. 2 goes 2 times in 4. This is 30 plus 6, 36 divided by 4 into 3, 12 cancel, 2 goes 7 times in 14. So 11 into 13 into 7, here if you look at it, 1001. So option D is your answer. A basket contains 6 blue, 2 red, 4 green and 3 yellow balls. If 2 balls are picked at random, then what is the probability that either both are green or both are yellow? So here total number of balls are 6 plus 2, 8, 8 plus 4, 12, 8, 12 plus 3, 15. Out of this 15, we should select 2 balls. That can be done in 15C2 ways. Total outcome is 15C2. Now favorable outcome means either both are green. Either it can be 2 green or it can be 2 yellow. So this 2 green and yellow can be selected from this 4 green and 3 yellow. You can ignore blue and red. So 2 green selected from 4 green in 4C2 ways. A bag contains 8 red and 7 black balls. 2 balls are drawn at random. The probability of both the balls are of the same color as. Here you are selecting 2 balls out of this 15 balls. And outcome is same color means you may get 2 red or 2 black. Now here there is only 2 selection and only 2 different colors. In that case, instead of calculating the probability for 2 red and 2 black, I will calculate the probability for getting no same color. That is, calculate the probability of getting no same color as outcome, then subtract it from the total probability. That is 1 minus, here total outcome is, total balls are 15. We are selecting 2 balls out of it. Now, favorable outcome means probability of getting no same color as outcome. So, when you select 2 balls, you should get 2 different colors. That is, one should be red and one should be black. So probability of getting 1 red from this 8 red is equal to 8C1, which is 8. Probability of getting 1 black from this 7 black is equal to 7C1, that is 7. So which is equal to 1 minus 56 divided by 15C2 means 13 cancel, 14 into 15 divided by 2 factorial. 2 goes 7 times in 14, 8 times in 56. So 1 minus 8 by 15 means 7 by 15. Option D is your answer. Here, this is because we are only selecting 2 balls. If it is about 3 balls, you are choosing 3 balls out of 3 different color balls, then you should not use 1 minus no same color because it is difficult. In that case, you should use same color probability. That is, here, probability of calculating 2 red or 2 black means total outcome is 15C2. And you may get 2 red as outcome means if you have to get 2 red as outcome, you should choose this 2 balls from this 8 red. That is 8C2 is your favorable outcome for 2 red. Now, you may get 2 black as your outcome means you should choose these 2 balls from the 7 black balls to get 2 black balls as outcome. So, which is equal to 7C2. Now, if you calculate, you will get your answer. That is, here this is equal to 14 into 15 divided by 2 factorial. Here 2 factorial we can cancel. That is, this will become 8C2 means 6 cancel. Remaining is 7 into 8 by 2 factorial. Here 5 cancel. Remaining 6 into 7 by 2 factorial. Now 2 factorial cancel from all these 3. Now 7 into 8 plus 6 is equal to 7 into 14 divided by 14 into 15. Now this is also 7 by 15. A box contains 5 green, 4 yellow and 3 white marbles. 3 marbles are drawn at random. What is the probability that they are not of the same color? Here, I have already said if you have more than 2 selection, don't try to find the probability of getting outcome as no same color. Instead, calculate the probability of getting same color as outcome, then subtract it from the total probability. That is 1 minus, here total outcome means total number of balls are 12. So, we are selecting 3 balls out of this 12. So, 12C3 is the total outcome. Now, favorable outcome means probability of getting same color as outcome. Which means, when you choose 3 balls, the 3 balls should be of same color. So, this is equal to 1 minus, when you choose 3 balls, you may get 3 green, or you may get 3 yellow, or you may get 3 white. So, this is the probability of getting same color. Now, to get 3 green as outcome, you should choose this 3 balls from this 5 green. That is, when you choose 3 ball out of this 12, your outcome is 3 green means you should choose this 3 balls from this 5 green. So, 5C3 is the outcome. Or, if you are getting 3 yellow as outcome, you should choose this 3 balls from this 4 yellow. So, 4C3 is the outcome to get 3 yellow. If you are getting 3 white as your outcome, you should choose this 3 balls from this 3 white to get 3 white as your outcome. So, 3C3. Now, this is equal to 1 minus 5C3 means 4 into 5 by 2, that is 10. 4C3 means 4. 3C3 means 1. Divided by 12C3 means 9 cancel, remaining 10 into 11 into 12 divided by 3 factorial. Now 2 into 3, 6. 6 goes 2 times in 12. So this is equal to 1 minus 15 divided by 220. 5 goes 3 times in 50. 5 goes 4 times in 20 and 4 times in 20. So 1 minus 3 by 44 means 41 by 44. If 2 balls are drawn from a bag containing 3 red balls and 4 blue balls, find the probability that they are of the same color, they are of the different color. Here we are drawing 2 balls. So we are selecting 2 balls. So first find the probability of getting different colors. So which is equal to, here total outcome. Total outcome is equal to, we are drawing 2 balls from this total 3 plus 4, 7 balls. So 7C2 is the total outcome. 2 balls drawing from 7 balls. Now favorable outcome means these 2 balls should be of different colors. Different colors means there are only 2 kind of balls available. So one should be red and other should be blue. So we should get 1 red from 3 balls. 3 red. So this can be done in 3C1 ways, and we should get 1 blue from 4 blue balls. So this can be done in 4C1 way. That is, you can directly write 3 into 4 as favorable outcome. Now this is equal to 12 divided by 7c2 means 5 cancel, remaining 6 into 7 divided by 2 factorial. 2 goes 3 times in 6, 3 goes 4 times in 12. So 4 by 7. So option A is your answer. That is, probability of getting they are of the same color means 1 minus probability of getting different colors. That is 1 minus 4 by 7 is equal to 3 by 7. 2 marbles are drawn successively from a box containing 3 black and 4 white marbles. Find the probability that both the marbles are black if first marble is not replaced before the second row. Here there are only 2 selections happening. So first marble not replaced before the second row means there is no replacement happening during this 2 selection. So here our outcome is 2 black marbles. And here this event is happening successively. So probability of getting first black marble is equal to, here there are total 3 black marbles and total marbles are 3 plus 4, 7. So 3 by 7 is the probability of getting 1 black marble. Now after selecting 1, remaining black is equal to 2 blacks. Total marbles are 2 plus 4, 6. So probability of getting second marble is equal to 2 by 6. There are total 2 black remaining and total marbles are 6. Now arrangement of these 2 marbles can be done in 2 factorial ways, but both are black marbles. So divide it with 2 factorial. So arrangement of this 2 black marbles can be done in one way. So this is equal to 3 into 2, 6 cancel, 1 by 7. Or you can do it in different way as well. That is, here total outcome. Total outcome is we are selecting 2 marbles out of total 7 marbles. So 7c2 is the total outcome. And in this, our favorable outcome is equal to getting 2 black. So to get 2 black as the outcome, you should select this 2 black from this available 3 black. So 3c2 is the favorable outcome. Now this is also equal to 1 by 7. Determine the number of 5 card combination out of a deck of 52 cards if there is exactly 1 ace in each combination. So each of this 5 card combination should contain 1 ace. So 1 should be ace and remaining are 4 cards. Now this 52 cards contain 4 ace, total 4 ace, remaining are 48. So this each of 5 card combination contain 1 ace and 4 other cards. So this 1 ace can be arranged in 4c1 ways because total available ace are 4. So this 1 ace can be selected from this available 4 ace in 4c1 ways. So selection of aces done in 4c1 ways. Now remaining are 4 cards. So this 4 cards should be selected from this 48 cards in 48c4 ways. This 4 cards should be selected from this available 48 cards in 48c4 ways. So this is the selection of combination of each of these 5 cards, which is equal to 4 into 48 minus 4, 42 gone, remaining 43 into 44 into 45 into 46 into 47 into 48 divided by 4 factorial. 4 goes 11 times in 44, 3 goes 15 times in 45, 2 goes 23 times in 46. Now, you don't have to calculate this, just take the digital sum. So, which is equal to 4 into 4 plus 3 is 7 into 1 plus 1, 2 into 1 plus 5, 6 into 2 plus 3, 5 into 4 plus 7, 11. So, 1 plus 1, 2. 4 plus 8, 12, 1 plus 2, 3. 3 into 2, 6, 6 into 5, 30, 30 into 6, 180, 180 into 2, 360. So, 360 into 7 into 4, 28, which is equal to 8 into 6, 48, remaining 4. 12 plus 24 is 36, 36 plus 4 is 40, remaining 4. 3 into 2, 6 plus 4, 10. So, here digital sum of this 4c1 into 48c4 is equal to 9. 1 plus 8, 9. Digital sum is 9 means check for the digital sum in this option. Here 7 plus 2, 9 cancel. 8 plus 3, 11 plus 2, 13. So 4 is digital sum. So this is not our answer. Here 7 plus 2, 9 cancel. 8 plus 8, 16 plus 3, 19. 1 plus 9, 10. 10 is digital sums. That's 1 is digital sum. So this is not our answer. Here 7 plus 2, 9 cancel. 7 plus 3, 10. 10 plus 8, 18. So 9 is digital sum. This can be our answer. Here 15 plus 3, 18. 18 plus 2, 20. 2 is digital sum. This is not our answer. So 778320. This is our answer because digital sum is 9. The number of ways in which a cricket team of 11 players be chosen out of a batch of 15 players so that the captain of the team is always included. So here captain is already selected. Captain is already selected means remaining available players are 15 minus 1, 14 players. So out of this 14, we should select 10 players because one player captain is already fixed. Captain fixed. So 10 plus 1, 11 players. So other players, 10 players can be selected from this 14 players in 14 C10 ways. So 14 C10 is equal to 10 cancel, remaining 11 into 12 into 13 into 14 divided by 4 factorial. 4 into 3 is 12 cancel, 2 goes 7 times in 14. So 11 into 13, 143. 143 into 7 is 1001. So option C is your answer. In how many ways can one select a cricket team of 11 from 17 players in which only 5% can bowl if each cricket team of 11 must include exactly 4 bowlers? When you select a team of 11, it must include exactly 4 bowlers. Remaining are 7 players. Now we have 17 players available, out of which 5 are bowlers. Remaining 12 are other players. Now we should select this 4 bowlers and 7 players from this 5 bowlers and 12 other players available. So this can be done in this 4 bowlers can be selected from this available 5 bowlers in 5C4 ways. And the 7 players can be selected from this available 12 players in 12C7 ways. Now this is equal to 5C4 is 5. 12C7 means 7 cancel, remaining 8, 9, 10, 11, 12 divided by 5 factorial. Now 3 into 4, 12 cancel, 5 into 2, 10 cancel, remaining is equal to 8 into 5, 40, 40 into 9, 360. 360 into 11 means 36 into 11 is equal to 396. So 3960. Option 4 is your answer. In a group of 13 cricket players, 4 are bowlers. Find out in how many ways can they form a cricket team of 11 players in which at least 2 bowlers are included. Here there are total 13 players, out of which 4 are bowlers, which means remaining 9 are non-bowlers. Now we have at least 2 conditions here. At least 2 means minimum of 2 bowlers or 3 bowlers or maximum of 4 bowlers, because we have only 4 bowlers available. Instead of calculating the possibilities for 2, 3 and 4, calculate the possibilities for 0 bowlers and 1 bowlers, because the 0 and 1 does not include in at least 2. So calculate the possibility of 0 bowlers and 1 bowlers, then subtract these possibilities from the total possibilities. Total possibilities means we have total 13 players available, out of which we should form a team of 11. So 13C11 is the total possibilities. Now subtract the possibilities of 0 bowlers and 1 bowlers from it. If you are forming a team of 11 and selecting 0 bowlers means remaining 11 are non-bowlers. So subtract this possibility from this 13C11. And if you are including 1 bowler, then remaining 10 are non-bowlers. Then you should also subtract these possibilities from this 13C11. That is, if 0 bowlers included, remaining 11 are non-bowlers. This should be selected from this 9 available non-bowlers, but which is not possible. That is, 9C11 is not possible. That is, you have to select 11 non-bowlers from this 9 non-bowlers, which is not possible. Then take the second one. if one bowler included from this 4 bowlers, which can be done in foreseeable ways. But here remaining 10 are non-bowlers, which should be selected from this 9 non-bowlers. That is not also possible. That is 9C10 is also not possible. So cancel this one. Which means our answer is 13C11, which is equal to 11 cancel, remaining 12 into 13 divided by 2 factorial. 2 goes 6 times in 12, 6 into 13, 78. Option C is your answer. You are selecting a cricket team of first 11 players out of 16, including 4 bowlers and 2 wicket keepers. In how many ways you can do it so that a team contain exactly 3 bowlers and 1 wicket keeper? Here, this available players are 16, out of which 4 are bowlers and 2 are wicket keepers. So the remaining are 16 minus 6, 10 other players. Now we should form a team of 11, which should contain exactly 3 bowlers and 1 wicket keeper. So remaining are 11 minus 4, 7 players, 7 other players. Now we can select this 3 bowlers from this available 4 bowlers, and we can select 1 wicket keeper from this 2 wicket keepers, and we can select the 7 other players from this 10 other players. So this can be done in 3 bowlers can be selected from this 4 bowlers in 4C3 ways, and 1 wicket keeper can be selected from this 2 available wicket keepers in 2C1 ways, and the 7 other players can be selected from this 10 other players in 10C7 ways. This because this is the availability. So this is equal to 4C3 is 4, 2C1 is 2, and 10C7 means 7 cancel, remaining 8, 9, 10 divided by 3 factorial. 3 goes 3 times in 9, 2 goes 5 times in 10. Now 4 into 2, 8. This is equal to 120. 8 into 5, 40 into 3, 120. 120 into 8 is equal to 960. So option A is your answer. Now there is one more question. Please do it yourself. In how many ways can a cricket team of 11 be chosen out of a batch of 15 players? So our availability is 15. If there is no restriction on the selection, how many ways we can choose? No restriction means available players are 15 and we should form a team of 11. So 15C11 is the selection if there is no restriction. If a particular player is always chosen, that is one player is fixed, one seat is reserved. So the remaining means this one is reduced from this available 15%. So 1% reduced from available 15 means remaining persons available are 14%. Also, one player we already chosen. So remaining players are 11 minus 1, 10. So our selection is equal to, out of this 14, we should choose 10. 14C10. Now, a particular player is never chosen. Particular player is never chosen means from this 15, we restrict 1. So available persons are 14. And we can choose 11 players from this 14. In 14C11 ways. So calculate 15C11, 14C10 and 14C11. A bag contains coins of 1 rupee, 2 rupee and 5 rupees. The total money in the bag is rupees 120. If the total number of 1 rupee and 2 rupee coins are 35 and ratio of coins is 2:5, find the probability of getting a 5 rupee coin if a coin is randomly picked from the bag. So these are denominations of 1 rupee, 2 rupee and 5 rupee coins. Now numbers of 1 rupee and 2 rupee coins are in the ratio 2:5 means this is 2 part is to 5 part. And total number of 1 rupee and 2 rupee coins are 35 means 2 plus 5, 7 part is equal to 35. Then 1 part is equal to 5. 1 part is 5 means 2 part is equal to 10 and 5 part is equal to 5 into 5, 25. So total number of 1 rupee coin is 10 means total value of 1 rupee coin is 1 into 10, 10 rupees. Total value of 2 rupee coins is 2 into 25, 50 rupees. So 10 plus 50 is 60 rupees. But there is total 120 rupees in the bag. So remaining 60 rupees is value of 5 rupee. So value of 5 rupees coins is equal to 60 means total number of 5 rupee coins are 60 by 5, 12. Now you are picking a coin randomly from the bag. So chances of getting, probability of getting 5 rupee coins is equal to, there are total 47 coins in the bag. So you are picking one coin out of this 47 coin. So total outcome is 47C1. And chances of getting 5 rupee coin means there are 12 5 rupee coins in the bag. So you have to pick one coin out of this 12 coin to get a 5 rupee coin. So favorable outcome is 12C1. So 12 by 47, option 4 is your answer. On a New Year day, every student of a class sends a card to every other student. The post delivers 600 cards. How many students are there in the class? Consider there are 5 students in the class. And if the first student sends card to all other students, he can send 4 cards. That is, he can send cards in 4 ways. Now, if the second student sends cards to every other students, he can send cards in 4 ways. Same way, third student can also send cards in 4 ways. So, one student can send cards in 4 ways. One student can send 4 cards. Then 5 students can send 5 into 4, 20 cards. Each of these 5 students can send cards in 4 ways. So 5 into 4, 20 is the total number of ways. Now, here total number of cards are 600. Here, if 5 number of people are there, this 5 number of people can send 5 minus 1 cards to each other. That is, if n number of people are there, n number of people can send n minus 1 cards to each other. So n into n minus 1 is 600 means to find this, take the nearest square value. 625 is nearest to 600. 625 means 25 square. So take 25. Now take the nearest values of 25. 26 and 24. Now you can see 25 into 24 is 600. So here this is equal to 25 into 24, which is 600 means n is equal to 25. Option C is your answer. In a Caroms competition involving some boys and ladies, every player must play exactly one game with every other player. It was found that in 105 game, both the players were ladies. In 300 games, both the players were boys. What is the amount of game during which one person was boy and another person was lady? Here, to play one Caroms game, you need 2 players. And in 105 games, both the players were ladies. Consider total number of ladies as W. Total number of women as W. Now, number of selection of 2 players out of this W players is same as the total number of games played by this W players, which is 105. Simply, n into n minus 1 divided by 2 is equal to 105, which is exactly same as NC2. That is, number of selection of 2 players out of this n players is same as the total number of games played by this n players. So here, W into W minus 1 is equal to 2 factorial into 105, which is 2 into 105, 210. Now, to find W, take the square nearest to 210, which is 15 square. 15 square is 225, which is nearest to 210. Now, W is equal to 15. That is, if you have doubt, take 15 and take the numbers nearest to 15, which is 16 and 14. Now you can see 15 into 14 is equal to 210. So 15 into 14 is 210 means W is equal to 15. Same way, here in 300 game, both the players were boys. Consider number of boys as B. So B into B minus 1 is equal to 2 into 300, that is 600, which means nearest square is 25. So number of boys is equal to 25. 25 square is equal to 625, which is nearest to 600. Because 25 into 24 is 600. Now we got total number of boys as 25 and total number of women as 15. Now, amount of games played by one boy and one woman is equal to 25C1 into 15C1. That is, take one player from this 25 boys, which is 25. and take one player from this 15 women, which is the number of games played by one boy and one woman, which is equal to 25 into 15, 375. So option 4 is your answer. 25 C1 is 25, 15 C1 is 15. From a group of 7 men and 6 women, 5 persons are to be selected to form a committee so that at least 3 men are there on the committee. In how many ways it can be done? Here, at least 3 men means minimum 3 men or 4 men or maximum of up to 5 men, because capacity of committee is 5%. Now, if you are including 3 men, there should be 2 women as well. Total capacity of committee is 5. So, 3 plus 2 is 5. So, this 3 men should be selected from the 7 men in 7C3 ways. And remaining are 2 women. 2 women should be selected from 6 women in 6C2 ways. Plus, if you are including 4 men, it can be done in 7C4 ways. Remaining is 1 woman should be selected from 6 women in 6C1 ways. Now, if you are including 5 men, 5 men should be selected from 7 men in 7C5 ways. Remaining is 0 woman. So, that can be done in 6-0 ways. So, this is equal to 4 cancel, remaining 5 into 6 into 7 divided by 3 factorial into 6C2 is equal to 5 into 6 by 2, that is 15, plus 7C4 is equal to 4 cancel, remaining 5 into 6 into 7 divided by 3 factorial into 6C1 is 6. 7C5 is equal to 5 cancel, remaining 6 into 7 divided by 2, that is 21. 21 into 1. Now this is equal to 6 cancel, and 15 into 5 is 75. 75 into 7 means 70 into 7, 490. 5 into 7, 35. So 490 plus 35 is equal to 525. Plus here 30 into 7, 210 plus 21. Now this is equal to 500 plus 200, 700. 25 plus 10 plus 21 is equal to 56. So 756. Option 4 is your answer. There are 5 singers, 8 dancers and 7 actors in a movie. A group of 6 members will be chosen to nominate in an award show. How many combinations of the members are possible if the group is to consist of all members of the same profession? So, the group should consist all members of the same profession. And group has 6 members. Group should consist 6 members. But you can see this 6 members cannot be selected from this 5 singers. So, which eliminated? Now, remaining 8 dancers and 7 actors. So, the 6 members can be selected from this 8 dancers in 8C6 ways, or the 6 members can be selected from the 7 actors in 7C6 ways. So, total combination is equal to this one. Now, 6 cancel, remaining 7 into 8 divided by 2 factorial plus 7C6 is equal to 7. Now, 2 goes 4 times in 8. 28 plus 7 is equal to 35. Option 3 is your answer. There are 5 singers, 8 dancers and 7 actors in a movie. A group of 6 members will be chosen to nominate in an award show. How many combinations of members are possible if the group is to consist of exactly 3 singers? Here, there are total 6 members in this group. Out of the 6, exactly 3 singers should be included means this 3 singers should be selected from this 5 singers. So, this can be done in 5C3 ways. So, remaining members is 3. So, this remaining 3 members should be selected from this 8 plus 7, remaining 15 people in 15C3 ways. So, this is the total selection of 6 members. 5C3 is equal to 5C2, which is equal to 4 into 5 by 2, that is 10. Into 15C3 means 12 cancel, remaining 13 into 14 into 15 divided by 3 factorial. Now 3 goes 5 times in 50, 2 goes 7 times in 15. 13 into 7 is equal to 91. 91 into 5 is equal to 455. 455 into 10 is equal to 4550. Option C is your answer. If 10 objects are arranged in a row, then the number of ways of selecting 3 of these objects so that no 2 of them are next to each other is. Here this is a special case question in combination. Special case in combination. So there are total 10 objects. And out of this, if you are selecting 3, that is 3 out of 10, then 10C3 is your selection. 10 objects are available. Out of this, you are choosing 3. Then 10C3 is the obvious selection. But here, there is a condition. That is, no 2 of them are next to each other. That is, you cannot choose objects which are nearer. You cannot choose 3 objects which are nearer. This is not possible. So, there must be one object between your selection. That is, if you are choosing the first one, you cannot choose the second one. You can choose any of the other objects. And if you are choosing the last one, you cannot choose the object nearer to it. So, 2 selection disabled. Now, the third one you can choose from the remaining. So, if you are choosing this one, there is no objection because you already choose 3 one now. Which means, if you are choosing 3 objects at a time, your availability is only 8 because 2 objects are disabled. When you choose one is disabled. When you choose the other one is also disabled. So 2 are disabled, which means your availability is 8. 10 minus 2, that is, you are disabling these 2 objects. So your availability is only 8. Out of this 8, you can choose 3 objects at a time. Out of this 8 available object, you can choose 3 at a time. So 8C3 is your answer, which is equal to 8 minus 3 is equal to 5 factorial. For 5 factorial, cancel in numerator and denominator. So remaining in numerator is equal to 6 into 7 into 8. In denominator, you have 3 factorial, 1 into 2 into 3. So 2 into 3, 6 cancel, 7 into 8, 56 is your answer. Option A is your answer. That is, you can choose 56 objects with this condition.